We are in AP Calculus, and today's date is Wednesday, January 22nd, so 1/22, 2020. Always messes up right there, whatever. I'm just going to say, yep, 1/22. Our objective today, Claire, is to...
Use both positive and negative differential equations to answer questions about rates.
There it is. It's a mouthful, and you're probably all wondering, differential equation, that sounds calculus-y, but what is that thing? And this is where I tell you the answer, and someone took my filled notes, so I'm going to go off of nothing.
You got this. All right.
Yeah, so they're basically rates, positive and negative rates. And I feel hesitant to even put positive and negative down because it's just an equation. It could be a negative equation, it could be a positive equation. Generally speaking, like if you come down here and take a peek at example number 2, one of these equations is for people entering and one of them is for leaving. E for entering, L for leaving, so I can kind of consider this the positive rate and the negative rate. So that's really what I'm all about today, talking about those rates. All right, so differential equations. I don't know what those 1, 2s, and 3s are. How about you guys give me some? All right, so number 1, let's see, my font size got all messed up from last night. I was doing random forms. They measure, oh my gosh, this is the typing conundrum. They measure how fast something is changing. Font size, let's make you 14. Let's make it 16. Let's make it even bigger, 18. That looks better, okay. They measure how fast something is changing. What do they also do? Units are always something, so I'll do like a blank something divided by time. And also, it's basically the same thing as velocity. AKA how fast your position is changing. I guess I can just change this to position because that will keep it all in one line. And I can come back up here and go like that. All right, so let's go to our first example. And all of our calculators are at the ready. Here comes an equation, and the equation got cut off. Ah! Oh my God, okay. Well,
Cut off too.
yeah, I know. It should have been 2 sine of 0.03t.
Why did it get cut off?
Because each of these is its own separate text box, and then if the text box isn't extended all the way, then it cuts it off. And for some reason, because yeah, there's a lot of behind the scenes work, but that's the gist of it. Who wants to read? Arrow, thank you.
What? Oh.
A cylindrical.
Fine. A cylindrical can is used to measure rainfall in Stormville. The can is initially empty and rain enters the can during a 60-day period. The height of the water in the can is modeled by the function S, where S of T is measured in millimeters. The rate at which the height of the water is rising in the can is given by S prime T, and then our equation is invisible.
Perfect. So I always like drawing a picture. Sometimes it's just a doodle. Sometimes it actually helps. This is one of those more, it kind of is a doodle because it doesn't help us that much. But I'm thinking of a cylindrical can. And it's just set out there, I don't know, maybe for the purpose of actually measuring rainfall, or someone accidentally forgot to bring in the gardening pot or whatever, and you're messing things up. But there it is. You have that can. It's being filled up with water, and it's definitely staying out there over 60 days.
How big is that? Is it like a soup can? Or is it like a barrel?
Yeah, you could do either or.
Because that changes the amount of rain by a lot.
It actually shouldn't change it because rain is theoretically consistent over an area.
The amount of rain.
But the amount in the thing.
Yes, so yes, the volume definitely changes quite a bit. I misinterpreted you, but the height that this question is asking about will be the same regardless. So we're trying to find the water height, the rate of the water height. So whenever you see the word rate, and this is something that I'm going to try to drill into us, rate means velocity. Rate means height of this function. This is a function of velocity. This is the rate. Underline rate in your notes. This equation right here is a rate. This equation is a velocity. Think of it as a velocity. I don't care what symbol they're putting here. It could be S prime of t, it could be E of t, it could be, I don't know, delta of t. I don't care. I just care that it's a rate. And almost always, I would say 99% of the time, I've never seen anything that doesn't give it to you as a rate. They're always going to give you some sort of rate. This is an equation of velocity. So if it's asking for a rate, just plug in 30 into your equation and you're done.
Oh, that's cool.
So plug this equation into your calculator.
And do the y thing or just?
Yeah, into your y. So y is equal to, and you can either graph it. There's a bunch of different ways. Either way, you do need to plug it in for your y1. So it's going to be 2 sine of 0.03 x, in this case, x. And you don't need to graph it. In fact, I would highly recommend not graphing it. It will save you time by just entering your equation and then second mode to quit out of it. The way that you plug in 30 is you go vars right, enter, enter, this y1, set up your parentheses, plug in 30, and hit enter. y1 of 30, that's how I read that, is 1.56665. And then,
5. Okay.
did you guys all get the same answer, hopefully?
Yes.
All right, and then we always in AP Calculus round to 3 decimal places. It's just a universal rule. So I come back here and I say, yes, this is 1.56, and you could say 6 or 7. I'm going to round in this case. I'm going to put, round, and put 7. And the units are important. And all of this units are going to come back and haunt us. Indicate units. What are units? This is a rate. This is a velocity. And as I just said in number 2, units are always going to be something over time. So what is our time? Our time is day. What is our something? Our something is...
Millimeters.
Where'd you see that? I don't even find it.
It's the third line from the bottom.
Third line from the bottom. Millimeters. Thank you. Days and millimeters. So this is millimeters. Oh, what's going on there? Millimeters per day. Cool. Done. That's A. If it's a rate, just plug it in. What is the rate of the water height change? Or is the rate increasing or decreasing? So now, this is a harder question. Whenever you see the words increasing or decreasing, I want you all to underline this. This means take the derivative.
Of the, like,
Take the derivative. This is something that I didn't really explain very well last year, but increasing or decreasing, if you ever see that anywhere, not just for this unit, for anything, it always means take the derivative of whatever you're talking about. Is the height increasing or decreasing? Is the rate increasing or decreasing? So if it was just talking about purely the height, and I ignored this word rate, if the water height is increasing or decreasing, I would be looking at the derivative of height, which would be, in this case, velocity, or this rate. But because I'm talking about the rate, the derivative of the rate, the derivative of velocity would be acceleration. So I'm really looking at the slope.
So that's double.
Yeah, so I'm taking the derivative of this function at time is equal to 30. So this one is going to be a math 8. A math button. Oh man. Focus on my handwriting. I should be able to get better. Math. And then you hit the number 8. And then you do your equation at time is equal to 30. So I'm going to do math 8. I'm taking the derivative of my vars right, enter my y1 function with respect to x at 8. At what? At 30. What am I doing? Again, so second enter to go back at 30. I don't know what I said there. At 30. And I got 0.037.
Yeah.
I don't care what that number is. I care about its sign. Is it positive? Is it negative?
Positive.
Positive. Yeah. So I'll say, and just for our notes, we can say that 0.037 is greater than 0, aka it's positive. It's positive, Mr. Sundell. Because it's positive, we know that it is therefore increasing. So this is how we actually type out our answer. Let me move you over. Oh, forgot to grab something. The T. So this is our final answer. We say that the rate of water height, I cannot spell I-G, oh that's it, right, height change, oh I forgot the E. Height change at T equals 30 is increasing, and then Y. You have to explain. You can just say increasing. Yeah, you could. You could say just. Should I just do that also? Increasing, because you say what is our function? Our function is s, so this would be exactly s double prime of 30
It's greater than 0.
is greater than 0, precisely.
Okay.
Part C.
Yeah, it's on the bottom.
Is the water height increasing or decreasing? This is not talking about the rate anymore. This is talking about the height. This is talking about, and I'll label this a little bit better, this is talking about s. S of t. This problem up here was talking about s prime of t because it's talking about the rate of the water height. If this is just talking about s of t and it's asking increasing or decreasing, I'm taking the derivative of s of t, taking the derivative of whatever it was talking about. So take the derivative of s of t, get s prime of t, which is the equation that it gave us.
Didn't we already do that?
Yeah, we did
It's the exact same question in a different wrapper.
So weird. Why?
So, and again, I only care about the sign now. The sign up here was obviously a positive 1.567. So we say, we can just type our answer because we don't have to do any more math. We've already done the math in A, as Claire said. So we say it's increasing. Why? Because we say s prime of 30, which is exactly what we just found up here, 1.567. S prime of 30 is greater than 0. Done.
Can you just draw an arrow in the test?
The cool thing about the test is they will look at everything. Or I think we're calling them Claire's now. But
Oh my
you,
god.
you can, they will look at everything. So if you're doing part C on the test and you did the calculations in part A, they know that you did that work. They're looking at the problem in its entirety. It's not like the grader just does C and they pass it off to the next grader to do part D. Yeah, so as long as your work is shown in part A, you're good. All right, let's see another example. These are the more typical ones that you'll find on the AP test, where it's 2 functions. And the words of wisdom from John Wynn is whenever they give you 2, turn it into 1. Make it as simple as possible from the beginning. So I'll even maybe write his words of wisdom, because again, these are things that I messed up last year teaching this. Turn it into 1 equation. That should be like your first step. If you see 2, turn it into 1. How do you do that, Mr. Sindel? Well, you come back over to your calculator. You do still need to type them both back in. Let's get rid of our y1. We don't need that anymore. Our new y1 is this function, 8,600 divided by that quadratic. So let's do 8600 divided by that guy. T squared minus 25t plus 163. And end your parentheses. You do need parentheses if you're doing the TI-83 plus if you're doing yours. I think you still need to do your parentheses unless you've changed one of your modes where you can actually see the fraction. There is a mode on the newer calculators to actually see this as a fraction of something over something instead of a little slash symbol. But yeah, make sure that you have parentheses, and then you do the y2 function as that one. Yeah, 9890, 9890 divided by, keep your parentheses, t squared minus 38t plus 370. And your parentheses. Okay. And then I don't really want to graph this thing. I could if I wanted to. But in y3, I'm going to say, I'm going to do the positive rate minus the negative rate. So E of t, y1 minus L of t, y2. y1 minus y2, vars right, enter, minus vars right, enter 2. y1 minus y2. So now y3 represents the overall rate change, the positive minus the negatives.
That's kind of cool.
Definitely.
And now we've boiled it down into a much, much easier problem. That's what we're going to do every single time that you see 2 equations. And they might ask you questions only about the entering equation, in which case we have a y1 function that we can use. But most of the time, the hard questions will come from that y3 function. Let's actually read this problem now. Okay, so we're talking about an amusement part. People entering this equation. People leaving this equation. Both are measuring, and let's underline our units because we're going to have to indicate units for part A. So are measured in people per hour. All right, and we're talking about hours after midnight, which is a weird time to think about, but I guess maybe the park opens at midnight. It's a weird park.
Like military time, so it's like 1, 2, 3, 4, 5. 'Cause
Yeah.
after
Yeah, so like between 9 and 23 means between 9 a.m. and 11 p.m. now, right?
Yeah.
Military time is really efficient, and I also
My
appreciate it.
phone was on military time.
That's weird.
Mine was, and then my wife was teasing me every time that I made a mistake, like, oh, you can't add. I'm like, okay, I'm just going back to the one.
I just have it memorized because the last year that's how like all German clocks are.
Whoa.
except
Perfect.
for the circle ones.
You'll get really used to it. That's cool to know. Thank you.
Oh, yeah.
All right, so we are finding the rate at which people enter the park at time is equal to 17. So there's a lot of questions that I'm going to ask you about this question. First of all, which equation are you talking about? L of t or E of t?
Oh,
The first one, EFT.
E of t is entering the equation, so it's only talking about E of t. So let's write E of t. It's only talking about that function. If it's talking about the overall rate, if it says the number of people in the park, that's talking about both of them. If it's only talking about entering or leaving, then it's only talking about the E of t or the L of t. Okay, next. Do we need to take the derivative of this at all?
Yes. Oh, no, it's not because it's already the rate.
This is already a rate. Let's write this down as well. This is a positive rate. This is a negative rate. These equations will always be given to you as a rate. So if it's asking for a rate, it's just asking you to plug in. All right, and at that point, we can just do it on our calculator. So we're plugging 17 into the E of t function. So we do y1 of 17 on our calculators. Let's get out of the second mode to quit. Let's clear out of all this stuff. We're doing vars right, enter 1 or enter, y1 of, and then I think we said 17, right? Of 17. I'm not going to make that mistake twice in a day. And I got 318.518, which is interesting because 0.518 of a person is roughly their torso, but moved up by a few inches. So,
How many
Round to the
digits
nearest
do you
unit.
go? Yeah.
and that is the great question, right? So whenever you're dealing with whole numbers, do what? Does it say
That doesn't make any sense.
find the rate at which people? Oh, it's just a rate though.
Yeah, I think it's fine.
It's fine as if I was talking about the number of people, then yes, you definitely need to have a whole number of people. If it's talking about a rate, rates are allowed to be decimals. So let's just write down the decimal in its entirety, which is 300 and wait,
18.
0.519.
0.519. Indicate units, people per hour. People per hour. And I suppose you could say PPL for people as an abbreviation. I don't know if that's standard or not. I don't know. But there's your answer. All right, let's try the next one. B, find the rate at which people leave. Which function are we talking about now, Gio?
The second one.
Second one, L of t. Thank you. So let's plug it in. So I do now vars right, enter 2. The y2 of, and it's still at 17, right? Yeah, at 17. And I get 760.769. 760.769. Again, indicate units, people per hour. So far, so good. Nothing too tricky. Let's do C. Find the rate at which people, the number of people is changing at 17. Now it's talking about which function in our calculator?
Y3.
Y3. This is our E of t minus your L of t, and you can put in your notes that's our Y3 function. So I go vars right, enter 3, Y3 of 17. And theoretically, what you could do is you could do what is 318 minus 760. You get the same answer. This is a far faster way of finding that, though.
You have to plug in 17, right?
Yeah, you're just plugging in 17. So negative 442. Negative 442.251. 251. Again, our units is still talking about a rate, so people per hour. People per hour. Is the amount of people in the park increasing or decreasing at time is equal to 17? Okay, so I know that it's very obvious to some of us, but let's reanalyze this question. We're talking about the amount of people, no longer a rate. But then we say, is that increasing or decreasing? That means we're taking the derivative of an amount, which means we're talking about a rate. So what we're really asking for is this ET minus LT a positive or a negative number? Is this number right here positive or negative?
Negative.
Therefore,
And it's decreasing.
yes. So let's go ahead and write that out. We can say decreasing at t equals 17, and our rationale is because we actually have to write, we can't say y3, they don't know what that means, so you have to say E of t minus L of t is less than 0.
You say EFT or you say U of 17? Because it's at a specific point?
Ooh, you are 100% correct. We should be way more specific. We should say 17 and 17. We might actually lose a point if I said E of t minus L of t.
But could you also do it E of t minus L of t is less than 0? 0 at n equals 17.
Oh yeah, because we did say at 17. I have a feeling, a gut feeling that you'd probably get full points because we said at t equals 17. If we just said decreasing because e of t minus l of t is less than 0, and you never mentioned 17 anywhere, you might not get the point.
Okay.
That's it. That's all I have for you guys.
Okay.
Questions?
Yes, sir.
Cool.